Hey YouTube, welcome back. Ever wondered how Uber or other ride handling services find nearby drivers so efficiently? Today we are diving into one of the key challenges in the system design, efficiently finding nearby drivers while keeping up with their constantly changing locations. The secret lies in a data structure called a QuadTree. If you have watched our video that we talked about designing Uber, we did talk about a QuadTree Map Service. And today we will try to talk about the QuadTree Map Service in details. QuadTrees are an incredible powerful tool used to divide maps into segments. So we will try to explain how they work and why they are so effective for systems like Uber. So imagine that we have this map. We have this square which represent the world map, for example. The quad tree will start by dividing this map into four large segments. We have one segments, two segments right now, and right now we have four large segments. Okay, and let's say that if the number of drivers in a segment exceeded a predefined limit, let's say that each segments have like 100 driver, and if one segment has exceeded that number, let's say, assume that this one has about like 200 drivers. So we will make these segments into four other segments. So each one could have like 50, 50, 50, and that assume that each one has 50. So this process continues until we reaches a level where each segment can no longer be divided. These are called leaf nodes. But this is makes it easy for our systems to start to search for drivers, because instead of trying to search in the whole map, which will take time, we try to search by segment. So if the rider is here, we try to search in its segments. If we can't find anything, we can go to neighbors segments and so on and so forth. It will make it pretty easy for us. But here's a twist. While the quad tree are great for static systems like finding restaurants and Yelp, they weren't originally designed for environments where locations change frequently. Because let's assume that we have one driver here. Actually, drivers changes their location. So they can go from one segment to another segment, one segment to another segment. So this is where the ride handling use case introduce some unique challenges. It's not pretty easy to find the driver. Unlike static systems, we need to update driver locations every few seconds, typically every 4 seconds. This requires us to modify the quad tree dynamically. First we identify, let's assume that here, we identify the driver's current grid. Let's assume this is the driver's current grid. After that, we need to check if their new location still fits within the same grid. If the new location, let's say that it's new location here, it's not in the same segment. If not, we remove the driver from the old grid and move them to the new one. So right now the driver is no longer here and it's here. If the new grid exceeds the driver limit, it needs to be split into smaller grids. So let's assume that each grid or each segment has maximum of 4, and right now we have, with our new driver, we have 5, so we will split this one into 4. So while this process sounds straightforward, it reduces significant performance overhead, like repartitioning grids and updating driver location can take time, especially in densely populated areas with many active drivers. To make things even more complex, the system needs to share real-time driver locations with rider during a trip. This means a QuadTree must support not only frequent updates but also real-time queries to tell riders exactly where their driver is at any moment. So, do we address these challenges? How do you address these challenges? We have to address it anyway. The key lies in careful balancing the QuadTree structure and update frequency. By fine-tuning the driver readable grid, optimizing update algorithms, and caching frequently query data, we can make this system both scalable and efficient. The QuadTree based system is a testament to how thoughtful systems design can solve complex real world challenges. It's a backbone of ride handling or ride hailing apps, ensuring a smooth experience for millions of users every day. So that's it for this video. We did have some introduction to the quad tree map, and we in the in on the future videos we'll try to talk about this topic more in details, because in my opinion it's a pretty important topic to understand. So that's it for this video, and see you in the future.